Hi guys, welcome to Learn Electronics Repair. This is the Air Con HVAC motherboard or mainboard that I looked at last week. Yeah, I made a video with this. And a lot of interesting discussion went on with this one. I wasn't able to repair it because I can't find anything wrong with it. This one is another one I have for repair which has a similar problem. Now this comes from a different manufacturer of the outdoor unit, the thing with the big fan on it that sits outside on the wall or on the ground. But if you look, they're basically the same thing. I mean, this one's longer, a bit bigger, but just looking, the replacement of these, okay, there's an extra capacitor in on this one, fuses here, high wattage resistor, just different style, relay, look here, that relay's there rather than there, so they're positioned different. This is the 12 volt supply, there, look, connectors, so you can see, I think, that these boards are basically the same. This one has an error code F4. This has an error code I mentioned on the previous video. I can't quite recall. This one I've not looked at before, so we're going to look today. But we might look again a little bit at this one. So what I figured out with this is that ground, live, neutral, and S, which is signal. And this signal is what is communicating with the indoor unit, the aircon thing on the wall that the cold air comes out of, And that, although I didn't trace it, goes to two opto-isolators or opto-couplers here. And these are mounted back to back. So when I say back to back, this one has the LED on this side, photo transistor on that side, and this has LED on that side and photo transistor on this side. So this can send information this way and that sends information that way. This one I couldn't get a good reading in circuit. I was trying to light up the LED with my multimeter in diode mode and measure across the transistor and resistance, and I couldn't actually get a reading. I couldn't get it to change. I took it out and it was okay. So that's about as far as I got with this one, and I'd just like to show you some of the comments that people made to that video. There was plenty of them. Some more relevant than others to what we're going to do today. This one from Rene Andra, basically talking about the big chip on the board that controls the three-phase motor. We can look at that, and they're explaining how to test these things. So what they're saying is that they tend to overheat or overcurrent, they fail. Says the only way to analyze these will be the data sheet. They usually have one high voltage DC input, matching ground, smaller voltage for driving the three bridges. So these are like MOSFET bridges, one for each phase of the motor. It has a plus and minus 15 volts DC, a separate 5 volts. So this comment is describing these devices, and they say they usually fail due to overcurrent or overheating, as I mentioned, okay? This one, US greedy men of no integrity. USA greedy men. So he is saying that he has a lot of these IPM modules, and I'll show you the thing in a minute if you're not sure what that is. And he says how to test them. So he says connect one end of your multimeter to the positive terminal on the capacitor, the big bulk capacitor, and then measure resistance to U, V, and W. Take a note of them, then go on to the negative terminal of the big capacitor, measure again. Are these readings close and consistent? If so, it checks out. If not, replace the IPM. So that's really handy. Thank you very much for that, and we'll try that today. This one, communication error between indoor and outdoor unit may be caused by the opto-isolators on both the inside and outside boards. Because it's the same on the other board that's talking to this one. Unfortunately, at the moment, I don't have the indoor board. I'm trying to get at least one of them here. This one, Will Doherty. So this is interesting. So this is where I was testing the opto-isolators in circuit. he's saying out of circuit, the voltage indicated when activated, I'll show you this on the video now, was 6 volts. It wasn't 6 volts, I had it set to resistance range. And in circuit, the voltage drop was 4. So you were never going to see the opto work in circuit as it was masked by the rest of the circuit. I suspect there is a fault in that circuit somewhere, as the circuit likely wouldn't sense any change whether the opto was isolated, so it was activated or not. Okay, so I'll just show you what Will meant there, and how with my experience from getting PCBs like this, it's almost never this PCB that's faulty. It's something else, okay? And I think that's most of the relevant ones. If you said something I missed it, you can chastise me on this video in the comments, okay? So what I'm doing here with Julie, who's helping me, I needed more hands than I had available. I'm actually reading here across the transistor. At the moment on the yellow flute meter, you can see that the meter is not connected to the opto-isolator, so it's not being lit up. And I see 4.159 kilo ohms, not volts. And then at this point, so I have the flute meter on diode test mode. I'm lighting the LED, okay? And we can see that's the voltage drop of the LED, and we still see 4.14 kilo ohms. So the resistance of the photo transistor isn't changing whether or not I have the LED illuminated. And I think at this point I'll actually look. I've removed my multimeter now, so the fluke is now removed, and this still reads the same. So you would expect that reading, which is the transistor, to change if the LED is illuminated or not, and it isn't doing, okay? So I then remove the opto-isolator to test it out of circuit, which is here. And you see, when I light the LED 1.0, this is reading now 6.3 kilo ohms. I keep slipping off, but you can see it, yeah? So what Will was saying is, because it's already reading 4 kilo ohms due to something else in the circuit, I'm not going to see it change in circuit. Outside of circuit I can do, so maybe there's something wrong with that circuit. I'm not totally sure that's the case, because remember, the transistor will switch on, so with some voltage supplied to it, more than my multimeter is giving it in circuit, it may well have an effect. But anyway, what we can do is test the readings again with the other one I have, okay? So in other words, we can look at these again in circuit, and we can look at these in circuit and see if it's reading the same. Although they're different boards, they look to be basically the same board, just same schematic laid out differently. The other thing we can do is look at these IPMs in here, how to test them, okay? So let's do that first. So Julie isn't here today, I have to do this myself. Let's see if I can do it on these. I think I'll try a different method. Okay guys, that's easy, yeah, just clipped onto my meter probes. Okay, so buy yourself some of these, often come like a pack of them like this, yeah, very cheap and they are really handy. We can now see on the multimeter 4.8 now, which is a similar reading to the board. You have turned the LED on, 838, 839, and nothing really happens. But the voltage I'm seeing here is less than the 1 volt roughly you would need to light the LED. So that would suggest to some extent the LED can't light up. Yeah. The LED can't light up according to that. Because you saw when it was out of circuit, it was about 1.05, which is what you'd expect for an infrared LED. Let's look at the other one. Okay. Red lead to where the dot is. 1.00. You can see on the black meter that the transistor switch is on. So that would suggest on both of these, and we'll just do the other one again, that the LED in that opto-isolator, which is incoming from the other board, can't turn on. So here we are again on the one I looked at on the previous video. Things clipped on 4.16. Yeah, I get the meter across the LED 842 and it doesn't light up. That makes sense because the LED wouldn't light up. We know that when we take this out it reads 1.05. Interesting. While we're here, let's just look at this other thing about these IPMs and how to test them. And then I'll come back to this area and have a little bit of a look around here and see if I can see any reason why that doesn't effectively light up. So this is this IPM, VNC, maybe that's the 5 volts, CN, WVU, various signals, plus and minus 15, like an op amp basically. Okay, then we have some high voltage pins here and then here, and this goes to the motor. Okay, so I'm not quite sure from the comment which side to measure to ground, so we'll do it from both here and from here and we'll see what happens. Yes, if there's any difference. I suspect it's probably these ones. I'm sure you will clarify for me in the comments to this video. And this one isn't marked, but we can see the same layout. It's probably the same device, to be quite honest. Get rid of that sticky stuff a bit. So let's see what we can see. We'll try this one first because it's marked. So P and N, positive, negative, yeah, on the large capacitor. So we'll go from P and we'll look to these. So we're on resistance range. Let's see what we can see. VWB, about 2 meg. VVB, similar, just climbing up a little bit. There's a capacitor in the circuit somewhere. That reads about the same. And then we look on these outputs. 1.76. So those all read the same as each other, they're consistent. Let's look on this one. So it's not marked on here, but I'm sure it's the same layout. This is the positive. So to here. Yeah. And on the outputs. So they're all consistent. Now we go to the negative end of the capacitor. Not sure if the polarity matters, but let's have a look. So that reads about the same. Same. Negative. Same. So they all read basically very similar between the two boards, and all the 3 phases read the same. So from the information we have, that means that is good. Okay, I could power this up the same as I did with this one, just to see if we have the 5 volts, if we have the 12 volt supply. Certainly while I'm here, I'll just check the fuse, which is good. And I'll just check this resistor. It looks a little bit distressed, but it could just be like the varnish on it. So this is 2K, which is exactly the same value as the resistor there. 2K. Reads good. But rather than just powering this up, first of all, let me just have a look at this circuit down here and see if I can figure out how this opto-isolator, the one with the incoming signal, is connected to this S or signal pin. Okay, that wasn't so difficult. So from here, I think you can just about see the trace comes down this way. That connects to this resistor here, 3300, which is 330 and no more zeros, 330 ohms. Goes to there, yeah. And that connects to this one. In series, that's 660 ohms. And that then goes to this end of this high voltage capacitor, 660 ohms. And the other end of the capacitor goes to here. Capacitor should read open. Yeah, but it couldn't have been short because otherwise that would have blown up. It could actually be open, I guess. So that's that way. So high voltage here through the capacitor through 660 ohms to this end of the LED. And then the other end of the LED. Well, this is your live and neutral. It's not going to go here. You would have sort of assumed that that might go to the negative end of the big capacitors. I'm not sure it does, but we need to kind of figure out where it goes, really. And so far, well, I can see there's a resistor and a capacitor. So this end of the capacitor goes, yeah, to the end of the LED. That end of that resistor also goes there. Looks like the other ends go to here. So other side of this. Get a good connection on it. Yeah. And yeah, so what value is this resistor? This is across the opto-isolator LED. It's 1.5K. What's it marked as? It's a bit hard to see. I can't see that clearly. It looks like it'll be 188. And let me clean the gunk off it and then see if we can see what it says. I'm sure you can see it clearer on this camera actually. 188 wouldn't make any sense. 881, well, that's 880 ohms. That's a very strange value. It's not like a standard value. And I doubt this is critical, so it would seem strange if it fit some really unusual value resistor in there. How about the other board? Well, that appears to be that resistor, which appears to be 152 or 1.5K. We can measure, just measure across this one and resistance range. What do we actually have? Yeah, 1.5K. So although the markings look a bit strange, that's the same. Yeah, interesting. Not quite sure still what that marking's supposed to say. Okay. The other end of this goes where? Quite probably to here, which is the transistor of that one. Maybe. No. Yeah, goes to there. Does that go to here? No, but that does. Yeah, that goes to there. There's a diode. That's the same end as is coming in the signal via the 660 ohms and the capacitor. Goes to there. Still not totally sure where this, well, this goes to that one. Where does that go to? I'm thinking this must come back somewhere. Somehow. It's got to be referenced to one of these three because these are the only three connections, sorry, four connections from the other end, and that one's ground. To the possibility, maybe, as I mentioned before, it goes to the negative end of this, which I'm sure it was the same point, let's just check, as the negative end of this voltage regulator. Does that go to there? No. Okay, this is a bit of a strange circuit, and there may be more of it than what I found, but basically, this is the signal coming into this optocoupler, we know that. And the other end of the optocoupler goes to this end of this, and that's a bit hard to figure out where it goes, but it's a bit awkward to get down there. It's a bit easier on the other board, and they're the same. Yeah, so this one is the signal coming in, and the other end of this opto-isolator goes to one end of the transistor on this one there. And the LED also goes to a diode here. And the other end of that diode goes to this 2K resistor, which reads 2K. And that goes to one end of this diode. And then the other end of this diode, this is where that capacitor was coming in. It doesn't connect across the capacitor, but it does connect back down to this pin. And if we look at these diodes, this one reads okay, this one reads okay. So I still can't quite figure out where this one actually goes to. I've had a bit of a look around at the various places it might go. So I'm still not really sure where the cathode end of this goes to. Effectively, it must be somewhere that's grounded with reference to what's coming in here. Doesn't go to hot ground. Hot ground is the same place as there, I think. Yeah, it doesn't go to hot ground either. Okay. I'm sure this is hot ground. Let's just double check. So tab of the regulator. Tab of the regulator goes here, which is hot ground. I measured this on the other board. Yeah, negative end of these. So it doesn't go to hot ground either. I'm not totally sure where that goes, but what I am more sure of is that the reason we see like 0.8 something of a volt across this, not enough to light the LED when we use the multimeter so it doesn't switch the transistor, is due to that 1.5k resistor across there. And I think I can prove this. So there is my 4k across the transistor, and with the multimeter in diode mode, not enough voltage to light it up. Okay, and here is my backlight LED tester set to 1 milliamp, so it's reading 21.8 volts right now, just upside down a bit. And if I short the leads together, that just goes to 0 because it's a 1 milliamp supply. So I'm going to try using this to illuminate the LED and see if we get 1.05 volts. Okay, so this is the positive end. Getting there. The reason I have these needles in here, by the way, is for testing Christmas lights, basically. So what do we have? For this on here, do we see 1.05? 1.0, sorry, it's 1.0 volts, yeah. And if we watch the meter here now, it changes, yeah. You see the transistor switched on down to 1 ohm, basically. Okay. Let it settle back down again now. .1k. In fact, just touching it with that is enough to actually get that to respond. Yeah, look, I haven't even got us connected to it. Interesting. What strange circuit is this? I mean, I'm now connecting one end. So the LED shouldn't light, look. It's switched on. And then it goes a bit nuts. There's a capacitor somewhere charging or discharging. I would say discharging. So I'd say that is working, but I can't really quite get my head around about how that happens, considering you can see on here the LED's not lit. Now it is. It stays. Okay, so I think we can say that the opto-isolator does work, and that given 1 milliamp, it's enough for it to light the LED inside the isolator, whereas off my multimeter it can't because of the problem, or rather not a problem, but the configuration of the circuit here, which has the 1.5k resistor across the opto-isolator. So I think we've solved that mystery at least. What I'm struggling to work out at the moment is how this signal is referenced. It must be referenced to the live or neutral. I can't see the path. I wouldn't be surprised if it goes through another capacitor, because there's a capacitor in one direction, but then there's also the 2 diodes and the resistor as well in the same direction. So need to think about that one a little bit, because if there's a problem in the return path, wherever it goes to, and it doesn't go to hot ground either, I can see that, then this would never light up. This is really weird, guys. The more I think about this, the stranger it is. Okay, so look, we have four terminals coming from the indoor unit, okay, or from the power. So we have ground, neutral, live, and signal, okay, and the signal goes to these optocouplers. So that's signal, there's the optocouplers, and we can see basically it's something like this. Signal goes through a capacitor, high voltage capacitor, 330 ohm, 330 ohm. What value is this capacitor? A bit hard to read, but it looks like it's a 250 volt XY capacitor, 470 picofarads, probably that 471. Okay, it's definitely a fairly low value, so we have that. And then this goes to the opto-isolator, like so. Okay, I can't figure out where this end's going, but what I can figure out is that we also have from here a diode going that way. When I tested it, we have a 2k resistor, power resistor. We have another diode, and that goes to there. And then we have a capacitor, which I don't know the value of, it's an SMD, and the resistor, and that goes to there. And this is 1K5. Okay, and as I said, I don't know where this goes to, but what I do know is that this also goes to the other opto-isolator, to one end of the transistor. And I think if the transistor is mounted that way round, if it is a transistor and not a thyristor or something, it goes there. Okay, so I have that, and this doesn't go back to live or neutral as I can see via any components around here, and it doesn't go to hot ground. So when I come in here with my multimeter, so I have one multimeter connected across here, and this is on ohms range. Yeah, look, so you can see it now, ohms. Okay, if I connect my other multimeter across here, I read about 0.895 volts, and it's not enough to turn the LED on, so this doesn't change. 4.2k, 4.1, 4.3, something like that. Okay, that doesn't change. If I connect my LED backlight tester set to 1 milliamp, and I connect it from here to here, this reads 1.0 volts, which is exactly what you'd expect, 1.05, but it doesn't have the resolution, so it reads a volt, which is an infrared LED. The LED lights up, and this goes down, basically to 0, yeah, or very close to 0. When I take it off, this goes back up to 4.2k. That makes sense. Yeah, that makes sense. What doesn't make sense to me, and I thought I knew some stuff, is that when I take my LED tester and I connect the positive lead to here, okay, with a pen that doesn't work, but I connect my positive of my LED tester to here, set to, well, it's what, 21.5 volts, 1 milliamp, but obviously that drops down to 1 when we connect to the LED. So if I connect my LED tester like this, yeah, and this lead is kind of like whistling in the wind, yeah, and I put the positive on there, that goes down to 0. So that LED is lighting up, even though I only have one connection from my admittedly mains powered LED tester, but it's only on a 2-pin wire, so there's no ground, and this is connected to nothing. This whole board is whistling in the wind, connected to nothing. That LED lights up because that goes to 0 with only one connection, and no current's flowing through the LED. We know there's no current flowing because this still says 21.5, and this suggests that this circuit doesn't need a return path back to one of the available wires that goes back up to the indoor unit, because by some voodoo or magic it can send a signal to here with only the one connection. Yeah, really? I've given you folks some challenges because I just can't get my head around this. This is a 4 AM moment tonight. I'll publish this today. This is tonight's 4 AM moment. Well, I tried to figure out how the hell that is doing that. Because I can't figure that out just yet. Can you guys? The only explanation I can think of is I am completely wrong and something else is going on, but what can go on? Because the multimeter is a multimeter. It's isolated from ground or anything else. I have one lead from my LED tester connected so no current can flow into this, and yet the thing seems to light up. But it can't light up because that doesn't say 1. So it isn't lighting up, is it? How do I see that go to 0? Well, I really look forward to hearing from you guys down there this time. Okay, and I'll see you all soon again on Learn Electronics Repair. Ciao for now.